Alright, this is like my third take recording this video because apparently I do things very fast. Anyways, so I am looking at a free body diagram. I want to recreate this. I built a tool called Civil Script. I'm going to go down and clear that. Civil Script, which is going to let me create this diagram. Now, I haven't quite built out the SI units and all the unit transferring and creating kilonewtons and whatnot, so that will be one of the next updates you get. But for now, we're going to work with newtons. We're going to assume these are newtons for now. We'll have an update on that soon. Anywho, so we have a 5.5 meter long beam. Cool, 5.5 meter long beam. We have a uniformly distributed load from point A to point B. A 50 kilonewton load at point C. A pin support at A pin support at D. Roller support at D. We at 3 meters from A we have point B. 4.5 meters from A we have C, and well at the end we have point D. So we're gonna get started on this. So in Civil Script, again, if you need any help with documentation, just click the little documentation button here. It'll take you to a new tab, and you will have the entire documentation now laid out for you to have fun with. So we are going to define a beam. The distance is 5. We do that. There we go, 5.5 meters. Next, we have a point A. Again, one thing you do have to realize is when you define point A as a capital A, point you have to constantly keep referring to it as capital A. If you do simple A, I'll show you what happens. But we have a something happens. I will show you what happens. So we have point D at 5.5 meters. So we have the start and the finish. We need the in between. So we'll go ahead and write a new point. We say point B is at 3 meters. Point C is at 4.5 meters. So we're going to set that up, and that looks about right as rain. We also want a pin support. We support pin at A. So this is what I meant by requiring the labels to be consistent, because say for this case I'm just going to say point A is with simple A. I run that, becomes simple A, instantly the pin disappears because there is no such point called capital A anymore. So we want to keep our naming consistent. Point capital A, pin at capital A. We say we want to support roller at point B. We pass and do that. Sorry, we want to roller at point D. We do that. Lovely. Next, we want a UDL from A to B. The load is 20 kilonewtons per meter. 20. We apply that. And again, if you have any confusion or whatsoever, stop the video, hop on the site, scroll down and find what I'm talking about, because again, it's right there. If I want to talk about loads, I'll just click loads, come down here, boom, baby. Yeah, point loads, UDLs, they are listed. Then we have dimensions, which I will get to next. Anyway, we have the UDL here, and I just talked about the point load, which is PL. We want to put it at C. The weight is 50 newtons in our case, because that's what the diagram we are building out has. It's 50 newtons over there. So we have that there, boom, boom. Now we need the now we need not a reaction, but let's just go ahead and list out the dimensions. So this is where we say dim AB, dim BC. We don't need dim CD, because dim CD implies that we have to do that, but we know 3.5, 4.5 whole distance 5.5, therefore it's 1. But if we do have a need for this, we can just say dim CD. Delete that. There we go. We have dim CD, A, B, B, C, and CD. Lovely. Now this is a free body diagram, so we do have to include our reactions. So if I remember properly, I just say react all, pass, and like I can say pass and visualize, and it will add the reaction forces individually. Now if you don't want to do that, if you want to be the crazy sociopath here and put up the reaction forces individually, that's also possible. We say react a x. When you do that, there we go get only the ax. React a y, because it is a comma y, because a is a pin support, it has both an x and y reaction. We have that. Next we need to put down react d y, because it is a roller, it lets you have movement on the x-axis, therefore there will be no reactions on that axis. There we go. And with that, we have created a lovely little free body diagram for you to use in your coursework, university assignments. Really, it's just entirely up to you how you plan to use it. So yeah, there we go. This is what we just created. If you do have any comments, just comments about the application, just drop it in the comment section, and I'll see what I can do about it. But yeah, I think guys, I will see y'all next time.